Example problem number 61, page 113, chapter 6, covering momentum. The problem states a 150 grain 30-06 bullet has a mass of 0.01 kilograms and a muzzle velocity of 900 meters per second. If it takes 1 millisecond to travel down the barrel, what is the average force acting on the bullet? Okay, so we're asked to find the average force that acts on the bullet. And what are we given? Well, the 150 grain, that's the amount of gunpowder that's in the shell. That's not relevant. Unless we knew the conversion between how much gunpowder and the average force, but that's more of a chemistry problem. So that's irrelevant. That's just what we call a distractor. That information we don't really care about. Also, the caliber of the rifle, the caliber of the rifle, 30-06, that's also irrelevant. So the relevant information is the mass of the bullet, 0.01 kilograms. The final velocity of the bullet, 900 meters per second. And the time, 1 times 10 to the negative 3 seconds, which is 1 millisecond. And we're also going to assume that the bullet starts at rest, right, before it's fired. Relevant equations. Well, momentum equals mass times velocity, and impulse, average force times delta t, is equal to the change in momentum. So this, now we're going to solve. This bullet experiences a change in momentum. It goes from rest to moving at 900 meters per second. So it has a change in momentum. The change in momentum is equal to its final momentum minus its initial momentum, which equals its mass times velocity minus 0, which is its mass times velocity, and final velocity. And so the average force times delta t equals change in momentum, which is mass times final velocity. Solving for average force, you get m times final velocity divided by delta t, which equals 0.01 kilograms times 900 meters per second, divided by 1 times 10 to the negative third seconds. And we're going to get kilograms meters per second per second. So kilograms meters per second squared, which is units of force, it's a newton. And we get 900. Those 900 newtons. So that's the average force that's exerted on the bullet while it travels down the barrel for that 1 millisecond to accelerate it from 0 to 900 meters per second. Okay? That seems, I guess, reasonable.